The first portion of the blood buffer simulation lab. I'm going to annotate this video as we go. Hopefully it's big enough for you to see it, but this is going to be part A on your procedure. It's kind of the bottom of page 2. And what you can see on the screen is that we have a flask, and we have 50 milliliters of DI water in the flask. Okay, we're only going to do one trial of this, so we're not going to have a part B over here where it says DI water number 2 where my cursor is pointing. We just have DI water number 1. So let's get started with the video. They're kind of going to check things off as we do them, and I'll show you guys each step of the procedure. So we have the 50 mils of DI water, and right now they've added 2 drops of phenolphthalein indicator, which is step 2 here, and they have swirled to mix the indicator. That indicator, remember, phenolphthalein is going to change colors. At acidic pHs, it is clear or colorless, and at basic pHs, it turns pink. So what just happened is 2 drops, it looked like, they just wrote a 2 over here. 2 drops of NaOH is all it took in pure water to turn the solution pink. Now, step 6, okay, we're down here at step 6. They're going to blow into the flask. What they're doing when they blow is they're adding CO2. And remember, CO2 with water makes carbonic acid, and that breaks down into bicarb and the hydrogen ion, which is acidic. So by blowing, you can see the hand was kind of in the way, but by blowing into the flask, they turned the color clear again because they dropped the pH of the solution back down below the pK of our indicator, which I believe is around 8. So now we are on the next step, which is step 7, and they're adding 0.05 molar NaOH, drop by drop, until the solution retains a pink color. And they will fill in how many drops it took. You can see after the addition of each drop or 2 or 3 that they are swirling the flask to mix the NaOH into the water. So this is what you and your partner would have done. You each would have had a trial with your own flask. You can see it's taking more than 2 drops on this round. And I want you to think about why that is, because one of your post-lab questions asks you if there's any trend in the data. So take note as we watch this video if you see a trend on the number of drops of NaOH it takes after the first, second, and third round of blowing, exhaling CO2 into the flask to turn the solution colorless each time, and the number of drops then afterwards that it takes of NaOH to turn the solution pink again. So it's definitely taking several more drops than it did the first time. And it looks like that pink color, it's faint, but it's persisting. So the number of drops it took after breathing in the flask for the first time, number of drops of NaOH was 12 drops. And now they are going to breathe into the flask. It does not take a lot of breath, but the solution is fully colorless again. So we're really down here on step 8. We're repeating step 6 and 7, and each time we're recording the number of drops after breathing into the flask that it takes to turn our solution in the flask pink again. So really during all of this, hopefully you watched the intro video. It was kind of long, I know. But hopefully you're thinking about why would it take more drops after you breathe into the flask, especially for the first time. Took 10 more drops of NaOH to turn the solution pink. for it to maintain that pink color? Why would it take more drops of NaOH? So remember, each time you add NaOH and swirl, if the solution remains colorless, it's because there are H plus ions in solution that have not been neutralized by the addition of the NaOH. But the moment that you add NaOH and it turns pink, it must be that all of those H plus ions that were created from breathing into the flask have all been neutralized by hydroxide, which is OH minus, ions from the addition of the strong base we're adding. So you can see the second round is done, and it took 16 drops this time to have that pink color persist in our flask. So now again, I know you can't see it very well, but they've inserted a straw and they're blowing CO2 into the flask to push the equilibrium of this reaction right here. If you're blowing CO2, you're increasing the concentration of a reactant. According to Le Chatelier's principle, you're pushing equilibrium towards the products, creating more H plus and bicarb. So now they're on round 3. What do you think? Do you think it will take more than 16 drops? We will find out. They're being extra diligent to add 1 drop at a time. I bet I know some people who would be a little less diligent. It's definitely tempting to want to add 2 or 3 or 4 drops at a time. But to really see an accurate trend, it's best if you add 1 drop at a time. So again, I know this is kind of taking a minute. Oh, is it pink? Is it not? Almost there. But we're trying to determine the number of drops of NaOH for that pink color to maintain. And looks like it is a faint pink now. The reason that it's being done on this white sheet of paper is so that you can see even the faintest color of pink, okay, against the white. So for this last round, you can see it took 22 drops to turn the solution pink and for it to maintain that pink color. So that finishes part A. And now the next video will be part B.